Hello, everybody. My name's Carl. I'll give you a little bit of my background on me. I first produced a yacht instrument system when I was at university. It was my final year project in 1980, and it calculated VMG. And as far as I'm aware, it's the first one to do that. I took it naively down to the America's Cup team, and they told me they'll never need anything like that. And I accepted what they said, and I went away, and I went to work in the music business. So I'm a software developer. I also do systems engineering over the years, mainly broadcast, to be honest, but some air traffic control. So that's my background, and I was also done a lot of sailing for 50 years, and I was also a lifeboat volunteer for 20 years. So. Uh, I am waterproof. Okay, so I'm judging by the results of the poll that people are not so au fait with some of these terms, so I'll try and explain them a bit more. The problem I was trying to address when I started this project, and I started it when ChatGPT appeared 2 years ago in September, I thought this would be great for writing software, and I started playing with it. And on my boat, I have AIS data. Now, you may not know what AIS is, but it's basically like find my friends for ships. So each ship reports its position over a VHF channel, and that can be received by the other ships. And so that looks like a sort of radar display, and they can see where each other are. But the low-cost AIS units that I would put on my low-cost yacht were very limited. So I wanted to have better quality information. And all these units produce a digital output which we can use to receive the AIS data. So AIS data is available. And the problem I'm trying to solve really is when I'm sailing across the channel or I'm crossing a shipping channel, am I going to pass ahead or behind of the ships that I see? And how far ahead or behind will I pass when I cross their track? Now, that is quite a different thing from CPA, and I'll explain a bit more about that later. Quick question, yes. AIS. AIS says Automatic Identification System. It's on the screen, yeah. But basically, it's a very simple system. It should be cheap, but unfortunately, it's not. It's getting cheaper all the time. Okay, so well, here's my transponder. So it's this is a 250-pound transponder, and it sends my position out and it receives the position of other ships. It shows a display. My ship is in the middle, and then you can see all the other ships there. But when there I am crossing a channel, and it's not really clear quite where I'm going to go and what's going to happen. It will tell me for any individual ship my closest point of approach, or CPA. It tells me how close I'm going to get. However, that doesn't tell me if I'm going to go around the front of it or around the back of it. Now, down at the bottom of the picture there, you can see a typical ship. Well, actually, that's not tall typical. It's a large, extra large. And I don't know if you can see. Oh, yes, you can see my little yacht there on the right-hand side of the display. So this is a sort of crossing situation. The big ship doing 25 knots. I'm probably doing 5, 6 knots. It's pretty obvious I'm either going to go ahead here or I'm going to turn around and go home. What I try and explain here is that the CPA typically indicated the closest point of approach for AIS systems is the closest you're going to get to the antenna on the ship. Now, this ship here is at least a quarter of a mile long. And AIS does allow for that. It does allow you to put the dimensions in. But generally, when it gives you CPA, it's giving you the distance to the antenna. So that's the one you can see on the left, CPA indicated. My real CPA, I missed the bow by this much. You understand this diagram? But what I really want to know is where am I going to cross? So, you know, this captain is going to get quite anxious if I'm not at least half a mile, maybe a mile ahead of him, where he can see me. And you can see the vision problem he's got on that picture looking ahead. Okay, so that's the background problem. So I go across the channel pretty much every year and back again. It's not just the channel, there's other channels where it's very busy. And if you do have to turn back from the situation, then your problems really start because all the other ships around don't know where you're going to go next, and they get very, very anxious. So there we go. So it's far better if you can work out what's happening well in advance, change your course a bit, change the speed a bit, and just go right the way through. And that's what we try and do with AIS. And it's before AIS, we'll do it with a compass and we'll be working quite hard. These days, I cross the channel on my own, single-handed, so it's good to have some assistance. Okay, I've explained AIS. We've done the poll, and so then I'm looking at economic hardware to use. I need a sort of display, and I don't know if you can see this on the display, but it's a little LCD 480 by 480. I'm going to pass it around the room and just for people to look at. It's an ESP32. It has a touch screen on it. It has an SD card slot in it, yeah. And I'll show you the ones I've got working. This is the one I did use on the boat actually. So the problem is really to get the AIS data onto different things. One is the iPad. It's possible to plot the ships on the iPad if you can get the data onto the iPad. So you've got to get it from the NMEA output of the transponder, and you've got to serialize it and get it into Wi-Fi so that the iPad can pick it up. So it's a two-step process, really. Here I am crossing the channel. So these shipping lanes, this was me crossing, I think the year before last, actually. And you go across these shipping lanes and you can see the little ships in green on here. That's quite a wide shot, so you can't see them very clearly. But if you look at those little green ships, that's what the AIS data is producing on my iPad. And that is facilitated by an ESP development board. In fact, this is a Wi-Fi bridge. You must be familiar with this little baby here. It's about £2, and it's got a 32-bit processor on it. Now on the back, I've stuck an RS422 converter, the power supply, and that is my Wi-Fi bridge. And then I wrote the software. Well, I say I wrote the software. I got ChatGPT to write the software. You can pass that around. Okay. So that is the problem I'm trying to solve. And there you can see, this is probably better for people who are remote. You can see now on the right-hand side of the screen there, the dev board and the two little boards super glued on the back of it. And I don't use an opto isolator. The NMEA standard is supposed to have an opto isolator, but generally that's because you're running the wires across the ship somewhere to another piece of kit, and you get induction, you get galvanic action. But if it's running straight off the instrument which is feeding into it, it's running off the same ground locally and the same power, you really don't need an opto isolator. But you can have one. You can have one if you want to just stick another one on the back. Okay, so and then on the left of the screen there are some of the displays that I'm running on the ESP32. This is a Guishan module. And apparently there's two variants, which might explain why at one point I found the pins were the wrong way around, and that caused me confusion for quite a while, actually. Okay, so let's have a look at the software structure. I asked in the poll about LVGL, and everyone said, no, we don't know what that is, really. LVGL is a sort of graphics and would allow me to sort of generate these. Just go back to the previous slide. These kind of big numerals, tables, scrolling, all that sort of stuff. That's all looked after by LVGL. And it's quite tricky. I found that quite tricky to use. So this is the software structure. We've got the ESP32 Gwischen hardware at the bottom. We've got Freertos so that we can have tasks scheduled at different rates, different latencies, things that can't wait can run, and things that can wait. And so I have two processors. I'll show you those working and their utilization a bit later on. And then we have, so this middle section, the sort of Battenberg cake part of it is are all the modules that I've half-inched from other people. They're open source. I've just bring them in wholesale. So there's a Wi-Fi module, UDP receive. Oh no, actually this configuration manager task, that's my one. I wrote that. It's a library. And that allows me to do some things with the SD card. LVGL, this is very sophisticated, usually, but not very sophisticated on the ESP32 because it's got quite limited resources. So, but it does do some of the things, and you can get an idea from what it does when I do the demonstration a bit later on. I have a task which is running over-the-air update, so it's possible to update these without a wire, and that's quite useful on the boat because these things can be tucked away in places and you don't want to be reaching in and plugging things in. It's better if you can just update them over the air. I have SD check task, which SD card check task. So that's checking the SD card is ready, dealing with any IO, filing system IO. And then at the end, I have little FS, and this is just a very small file system, which allows you to store non-volatile memory and non-volatile data that you want to keep between powers. It allows you to store it on the ESP, whether you've got an SD card or not. You can store a little bit without an SD card. If you want to store a lot, you need an SD card. And it's got a socket, so I was tempted to use it, and I did use it. On the right here, you'll see that these little blue squares just tells you the screens I've got. And these acronyms will be familiar to sailors, but speed over the ground, how fast am I going? Course over the ground, which way am I going? I've got an AIS screen, we'll go into detail, so that's proprietary, I've got a detailed vessel screen, so I can look at the AIS data for a particular vessel in more detail. I've got a log screen, so it's just like your car odometer, really. You can see how far you've traveled today. You can reset it and it will clock up again. And that needs to use the SD card, obviously, because you've got to keep where you've gotten to. VMG, I mentioned at the beginning, this is your velocity made good into the wind. It's a component of your velocity that is directly into the wind, and it's an important thing for a sailing boat to maximize. And so I put a screen on for that. I've got a screen for the depth, and I've got a little starting tool to help you starting yacht races, which is probably cheating, but anyway, I thought it'd be entertaining to do, so I've done that. So that really, let me just see what my next slide is. Oh yeah, this explains the demonstration, how I'm doing the demonstration. So I have a little Wi-Fi network here, and on the boat, the AIS transponder streams its NMEA 0183 to the little board I just handed round, the Wi-Fi dongle, the Wi-Fi bridge, and then it goes on to Wi-Fi, and these other units then pick that up. However, for demonstration purposes in here, I've got a Raspberry Pi generating the data, some of which has been recorded from the AIS transponder. So I use that as my test base, and I've added to that data depth information, wind information. So there's a constant stream going, and the Raspberry Pi on the desk here is putting that out as UDP broadcasts over the network so that we can see the AIS data. And the AIS data can be read by my iPad running Navionics, which is a very common package for the iPad that people use for navigating. I use it almost exclusively for navigating. And it can be picked up by the ESP32 here. Now I'm going to try and show you that all working. So there's going to be a little bit of clicking, and let me just check now that what's the next slide? Yes, okay. So this is where we demonstrate. I'll do the demonstration, and this is to remind me to show you there's a web server on here which allows me to set parameters using any kind of browser, and it will also show me the 2 cores and the latency I'm getting on each core. So when a task says I've got to do something, how long does it have to wait? That's really quite important. Okay, so let's try and switch to the demo. So the first place that the data will turn up is on the iPad. Now, how can I just share this? Share screen. Can you see that now?
Yeah.
Okay, so that's the iPad running Navionics. So the little red arrow is my boat in this, it's artificial data. Actually, the other ships are not artificial data, but so this is quite good for your AIS data compared to the transponder. You can now see, where the ships are, where they are in the shipping lane. And so this is a big improvement, and that's just with the dev board. This thing, that's what that's doing. It's taking it from the transponder and putting it out as a UDP broadcast. So my ship is programmed to sort of go in a little square there with a little bit of noise, so you can see it moving, and that's speed. On the bottom left, that's the depths being returned from the echo sounder. And that's what you get from the iPad. Okay. And now I will try and show you the demo of the unit. Oh, I need to go stop screen sharing. And I'd like you to stay on my camera if you can, Richard. So are you getting? Yes. Can we switch? Can you switch to my feed for?
It should be.
Yeah. Or is that? Yes. Okay. So there you can see the ESP receiving course over ground. We have. Well, that's clever. You've put us both up, right? We've got a little symbol to indicate it's picking up Wi-Fi. It's green, indicating it's getting data. There's a little symbol there to indicate there's GPS data embedded in it, because GPS isn't brilliant on the iPad. So I use the SBAS GPS that is working on the transponder. And the SD card symbol indicates the SD card there. So this is my course over the ground screen. It's just showing my course. It's got a compass, an edge reading compass. You can invert this if you want to have it strictly like an edge reading compass, but I quite like it this way around. Okay, I'll just go back to the beginning where I have speed over the ground. So that's our speed in knots. Course over the ground. And then we have the AIS page. So this shows the ships being reported. And there you can see one's turned pink. So they change color depending on the risk. And the icons also indicate things. So the purple one with a little arrow is indicating he's turning. So professional level AIS transceivers can actually have a lot more data. So he can tell you he's turning at this rate. And so this means you don't know where he's going to go next, really, but it's quite useful to be able to see that early. And you don't get that from a normal AIS unit. So this will tell you he's turning, whether he's turning left, turning right, what rate per minute he's turning. Because the ship's going around in a square, every now and then it will come into conflict. So there we go. We can see now several ships have come up red. We've got their azimuth. That is what is the bearing to the ship. Their closest point of approach. So some of those are quite close. That one I'm going to hit. And the time to the closest point of approach. So how long before I'm going to be in danger. And then the last field is the one that I'm calculating that I really wanted. That is the cross. So if it's plus, I'm passing ahead of the ship and allowing for the length of the ship as well, which is important. So this will be telling me if it's plus, I'm passing ahead. If it's minus, I'm passing behind. So, 200 yards behind might be fine in some situations. So, but 200 yards in front is definitely not fine. So that is shown in real time, all the time, for those vessels. And this is the thing I really wanted, and that's been really useful. Then I can also, there's a filter here, so I can put the risky ones up and I can have the danger ones up. Okay, so that's that. Next page. I'll zip through this because you're not so interested in the application, and I'll try and spend a bit more time on the development at the end. This allows me to look at any one vessel. I can step through the vessels. It'll start with the nearest one, and I can choose one, and it's telling me other information about the vessel, what class its AIS is, and I thought it'd be nice to add in the ability to show when the vessel was last spotted. So when you last came within a mile of this vessel and you saw it, and when I'm sailing on my travels, I see a lot of other yachts and I don't always recognize them. So it'd be nice to be able to say, oh, I saw this one at this date. So I record that data onto the SD card. When they get close enough, there's a range at which I record them. And it has a way of showing it where I can show a range of dates as well. So that's the vessel page. The log page is pretty self-explanatory. We just got an all-time log at the top, and we have two resettable logs. So I can reset this one, and then it will start counting up, so I can tell how far I've gone. And then VMG will be familiar to a lot of people who have sailing instruments these days. Now it's absolutely mainstream. In this data stream, I have got NMEA wind data, and so it is using that. If that data is not present in the feed, which is the case on my boat, I can tell you I don't have a wind transducer that generates NMEA, then I can set manually the apparent wind direction and speed, and I'm pretty good at guessing that. So that's quite useful for me to tell how well the boat's doing. So that's a VMG page. Depth, it's not very sophisticated, but there you go. Plain old depth. And then this is a start tool. I'm not going to explain that to you, but basically you can mark each end of the starting line. And then when you're closing with the line, it will tell you whether you're going to start early or late, and you can get in the right position. Okay, so those are the only screens I have at the moment. The most interesting one probably is the AIS screen. And I've shown you how it appears on the iPad. So that's the demo, really. Actually, there is one other thing I can show you, which I said I would do. And that is to share screen again. Excuse me a minute. I'm just going to try and put up the web server so you can see the processor's actually working. Now I'm going to switch to Really on the iPad. Okay, so because the iPad's on the same network, it can see the web server that's coming from this square display that I've shown you. And these are a few parameters that we can set. It's all set with a little configuration file that's recorded in a little file system. And these are all fairly self-explanatory. You know, how far ahead of the ship do I wish to consider dangerous? You know, so I can put that in there, and then it also has my MMSI number, which identifies my vessel, and other stuff like that. Oh, I don't mean to save that. It's going to restart it. Oops. Finger trouble, sorry. Okay, so there we go. I'll put the screen back up. Now, on the device, I've got the AIS screens showing, and it's having to do some work. And you can see at the bottom of the screen these two pie charts are showing the latency for the two cores on the ESP32. So the left one is the sort of slow response time processor, and the right one is for the fast stuff that I need to run quickly. So if I put the VMG screen up, it'll work much harder. And then you see, you know, sometimes that's jumping up to 100 milliseconds, 120 milliseconds to schedule. So I need to know all the tasks on this processor can tolerate being delayed for 150 milliseconds without any problems. And the ones that are dealing with the radio, the Wi-Fi, these are on the other core, and they have to run pretty darn quick. And so you can see that's very rarely going above 5 milliseconds. Okay, so that's the demo. Now I'm going to go back to here. And I'm going to try and share. Oops, it's decided to go from, we have to go from the beginning, excuse me. Oh no, here we are. Okay, so then we come on to the development environment. So, you know, how we've written the software to do that. Before I talk about that, it's worth saying that you know, the basics of what this is doing is applicable to a whole range of applications. And so in producing these kind of, using these libraries, I wanted to have it such that I could do other things. So when we get to a bit, I'll try and demonstrate if we've got time, I'll try and demonstrate a bit of the development environment cycle and using the AI to rewrite the software. It's very likely to be an exciting demo because it probably will go wrong. But I will, just to make the point, I mean, only the people in the room can see this at the moment, but I have here a little network analyzer that's basically using all the same stuff, and it's showing me all my things on the network. And I'm going to use this to show how we can change the software. So let's talk a little bit about the development environment and what you need to do this. So I use a thing called platformio. I don't know, anybody in the room used that before? Yes, okay. So it is a bit more complicated than the sort of default Arduino development environment. And frankly, some of it is a lot more complicated. And I use the AI all the time to explain to me what to do with the development environment. And this is a key point, really, that I'd like to, key lesson learn is, you know, yes, it is more complicated with platformio. And I'm logged into GitHub. I'm using GitHub copilot, and I pay for the AI, and I use it to help me configure the ini file. At the end of this at the end of this presentation, I've actually shown you my ini file because this is a difficult thing to get right. And something wrong with the ini file stops it working. It's quite hard to work out what. The AI is quite good at helping you with that. Okay, so that's the environment I'm using. vscode, platformio, GitHub. Okay. I'm using the source control on GitHub because when the AI runs rampant and does something and you think, oh no, I really didn't want you to do that, you can roll it back. And that's quite an important thing to be able to do. Occasionally the AI gets ideas above its station and starts, doing things with your code. So let me see. VS Code, platform, GitHub, Copilot, version control. It's worth paying for the enhanced AI service at the time of writing. I do find actually that in the mornings it's quite good, and in the evenings, I don't know whether they get short on power in America, but it's not so good. It just seems to be a bit more silly, a bit more stupid.
So it's not just slow, it just starts doing weird things.
Yes, it doesn't respond any slower. It responds lightning quick, but it's not as good. Yeah, I think it's a bit like dealing with a sort of gifted child, really, dealing with the AI. And
So can we just blame the Americans?
I can't blame the Americans. It's got this talent to do things. I mean, you saw the web server, it's so neatly laid out. I can't tell you how much work and aggravation that is to try and sort that out. And the AI is able to do that perfectly. And in fact, mine is all derived from a file. So if I change a file, then the entries change. So you don't. But getting that to lay out correctly is quite difficult. And the AI did a fantastic job on that. So things like spewing out HTML, it's absolutely fantastic at that. And I'm terrible at that. So that's good. But it's like a gifted child. So it does has these sort of brilliant things it does, and then other things where it's really, really stupid. It struggles a bit with Freertos, to be honest, if you don't keep an eye on it and say, have you done the best practice Freertos here? Or did you just put a delay in, or did you do something stupid? And it's, oh, you're quite right, I'll go and fix that. So it's a bit like your child saying, have you tidied your room? Go back and tidy your room. Okay. LVGL also was quite a challenge for me it takes quite a lot of resources. The ESP, a lot of the screen structures require static RAM. They won't do with pseudo-static RAM. They want static RAM because they're using a DMA engine to push them out and to get very efficient operation. And on the ESP32, you haven't got too much of that. So you've got to be quite careful about how you deal with that. So that took a bit of my time. So that really, I think that concludes my presentation. Did I miss a slide? I've just put the contents of the ini file up for you so you can see what's in there. And I'm going to make the network analyzer library available. So if people want to play with it, you can buy yourself one of these. I bought these for £15. They vary in price on Alibaba, AliExpress. You can get them for about £15. If you see them for £6, that's too good to be true. You're probably just going to get a bit of wire or something to connect them. So watch yourself on AliExpress. But 15 to £20, you can buy one of these. I'll make my library available. You can download that onto there, and then you can do some of the things I've done. So what I think that really concludes my presentation. I don't know how much time we've got, but if we've got a little bit of time, what I think I'll do is take questions now on this part, and then I'll show you what it's actually like to say to the AI and see it rewrite the software and see the function change if you've got time.
Yeah. So let's do some questions. So a few questions in the chat there. Whether or not you're using the ESP IDF or Arduino framework for ESP32?
I did use the Arduino at first and very quickly moved on from that. I haven't used the expressive EDF, which the nice thing about that is it takes FreeRtos as given. Everything runs on FreeRtos,
Right.
and so that makes it somewhat simpler. I don't know what the copilot options are for that development environment. Okay, yeah. Next question.
There's a question about how you get the vessel data into the ESP32 and where it comes from.
Okay, I probably didn't explain it very well. Well, the vessel data, all of it comes down the NMEA 0183 standard, which is a very old standard. It's just a serial line. So on some of my trips through Amsterdam main canal, I've had many more than 500 targets, and they're all coming down this wire, and the ESP deals with those all fine. So that's the vessel name, where its antenna is on the vessel, what class of it is, what its next port is. A lot of data can be sent.
Yeah.
The real-time data is sent more frequently, and the less real-time data is sent less frequently.
So how does it work with like these, you hear about these shadow fleets?
The shadow fleets just turn it off. You're not obligated to have it on. Well, commercial vessels are obligated to have it on, but leisure craft are not obligated to have it on.
Right. So if you have like the Russian tankers that are dark
you
fleet,
mean I
they would
can't
just
see
turn
them?
it
Yeah,
off.
I can't see them. Yeah, I could slam right into one. I could see them on the radar if I was lucky.
Right. Yes, they're huge. So it's not like you're not going to see them. It's going to,
Well, if it's foggy, you won't see them. Yeah.
oh yeah, I guess so.
I mean, that's what an important part about the AIS is using it in fog. So those vessels above a certain size are mandated to have AIS. The Russians ignore that.
Is it hard coded? Like you can't like change your vessel name or like that. You gotta,
Yes, there are things on the sets. The accredited sets are such that you can't change it because that's a kind of sabotage. If you change the vessel name, it can cause confusion, or you change the vessel size.
right.
Somebody could sabotage your vessel, sort of thing. So generally, they have a sort of set up once arrangement where you put that in and you can't reset them, but they all have a back door which allows you to reset them. So it's kind of pointless. But yeah.
So I had a question about if you're gonna start again from ground zero, like just say you want to do version 2 or version 3 or whatever number version you're on, what would you do anything differently, or you just essentially end up with the very similar system?
I think I would end up with something very similar. I'm very pleased with it.
Right.
It's been very reliable. It's not waterproof, but I mean, there isn't much that is waterproof, to be honest. I mean, it's very difficult. If you make something really waterproof, it normally gets water in it, and then it steams up and you can't get it out. I normally drill a hole in the bottom to let the water out.
Right. So it's very robust, and you haven't any
I haven't had any problem.
reliability
The
issues.
unit is incredibly robust.
Yeah.
But generally, I have mine inside. I have it a sort of little cover area. I have it in there so it doesn't get wet.
And do you ever have to like stop in the middle of the channel and say, "Oh, got to like reprogram something like that," or is it all just?
I have had problems with the boat power supply. My wiring is not up to our friend's wiring, which was awe-inspiring. Well, you can see what my wiring's like.
Yes.
Yeah. Important thing is to have it fused so that if anything goes wrong, it's not going to cause a fire.
And what's been your total development time? Like, is this a project going on for years and years? Or is it?
No. Well, I sort of work on it part-time for 2 years since ChatGPT first came out. So initially, trying to get ChatGPT to just write one little function was quite hard work. But I was fascinated by it. I was thinking, well, it actually did quite well. So for example, asking it to write a checksum routine for your NMEA word, which has a checksum. It's a painful thing to do as a person. You always find you've missed wrong byte. You've taken a checksum in the sum, whereas ChatGPT from the get-go did that perfectly.
Right.
But if you ask it to do something big, then it became more and more, it became much, much better at that over time. And literally 2 months goes by and it improves significantly. They bring out the next version and you think, wow, this is so much better than the last version.
And is the AI thing central to your development process, or are you just doing it because for a hobby type?
Oh, well, I was interested in it,
Yeah.
but I tell you, once the AI is writing good software for you, you just do not want to do all that. Oh, I've missed a semicolon thing.
Yeah.
AI doesn't miss, well, it does sometimes make typos, actually. It's quite weird. But generally, this software, I would say, is entirely written by the AI.
Huh?
I have said, no, you can't put a task there, or you must schedule this, or you must use a mutex here, a lock, or a semaphore. Um, and and normally it says, oh, you're quite right, I'll fix all that. It often tries to do better. But the software is written by the AI. The layouts are done by me. For the network analyzer, this was only 6 days work, okay? We'll have a look at that a little bit when I do the other demo. That was only 6 days work. I'm going to make that available to anybody who wants it and to use it.
Did you play around with more than one AI?
Well, in the Copilot, you can choose between them. So you have ChatGPT, you have Gemini 3, I think. You have Claude Sonnet 4.5. That is my favorite, I have to say. And you can just switch between them. And you can say to one, oh, ChatGPT says this. What do you think, Claude? And Claude will give you a different answer. So, it really is incredibly conversational. And bear in mind that the standard for NMEA is a pay-for document, and there are people who've reverse engineered it, but the sources are not too great online. Because the AI aggregated all that data, it made a few errors, and they were apparent. And you tell the AI it's made an error, it says, "Oh, I may be out by one on the decoding of where this, on the parsing of this message." So it then tries again, and you say, "Okay, that looks good," and off we go. So very positive experience. I think the one thing that I would say is really important, and it's going to be a kind of seminal moment, is when you can say to the AI, generally when the AI changes it, it gets more complicated. You can say to the AI, I want you to simplify this, and it struggles to do that. But I think very soon now, any moment now, I'm talking about within the next year, the complexity will go down. The AI will just say, I'm going to rewrite this now. I understand what you want. And it could be done much simpler like this. It's not really doing that quite yet. It may be in Elon Musk's office doing that because he's got enough power going to it, but it isn't doing it on my Copilot. That's my experience. But I had a new version just 2 weeks ago, and it's considerably better than the one before. So it's always improving.
The VMG screen,
Yeah.
so the round compass on it. How much work did you have to do to generate that data? Was the algorithm you used there written by ChatGPT?
Well, I would talk to ChatGPT. I would say, I want the apparent wind here. I'd like the apparent wind arrow to be purple. I want a compass card now. I want degrees on it. I want those marks. LVGL did struggle with performance a little bit there because I've got every couple of degrees on there. But the layout I discussed with the AI and say, oh no, that doesn't look right, or it's too big. Can you make it smaller? And you just push it around, and then this is what they're doing with websites now, isn't it? You just look at it and say, well, that's not quite what I want for my business. Can you just change this to that? And it's a very good way to deal with it. So anyway, that is all LVGL. Any other questions? Or I mean, I'm happy to keep going on questions, or I'm happy.
Oh, there's a few questions in the chat.
I can't see the chat at the moment. I'm not sure why you just.
Oh, so let me just read some of them out.
Yeah.
So yeah, whether or not you could use a cheap display, cheap yellow display instead of the display that you got.
This one's £15. That's pretty cheap. And it's got a touch screen, and it's even got a sort of case. This is just the front of the unit. You can also get a back for them, which has relays in, so you can then control things. Then people use them for light switches and things like that.
Yeah, it could be that he's wondering whether or not you could get something bigger that's.
Oh, yes.
easier to use or?
Yes. You could get something bigger. And of course, using a web server, you could serve it up to your phone if you wanted to.
Okay, all right.
You know, and you could do that with something like this. You wouldn't need to have something with a screen on it. You could just put a web server on this and serve it up to your phone.
Yeah.
But I'm fed up of looking at things on my phone. I'd rather have it in front of me.
So I think you've already answered which AI model you find the best. So you said Claude or
Well, best for certain things. The nice thing about Claude is it gets the syntax generally right and doesn't make too many errors. However, if you want big thinking, ChatGPT is quite good. If you want to talk to ChatGPT about something a bit wacky, it's quite good. But then when it does the code, it gets a bit overambitious. You know, some of them will just chuck everything out and then they can't put it back together again. And you say, well, now look what you've done. You've ruined my program. So then you roll it back and then let them have another go.
Yeah.
Yeah.
Yeah, something in the chat about somebody else that's doing similar things. May want to look at that later.
Richard, do you want me to jump in there if that's okay?
Yeah, sure.
The chap I met was actually a chap called Dagnall Clutterbuck, lives on Hailing Island. He seems to be doing something very, very similar to you, using the same display, the cheap yellow display with ESP32, slightly different functions from you, but very similar.
Yes, I came up on my Facebook feed yesterday, Dagnall Clutterbuck, I think that's his name, and he's done a thing for Practical Boat Owner, which is using this same device, which is, you know, good reinforcement that it's a good device for this. Is about the right size to use on a boat. He was showing course over ground, speed over ground, but he wasn't using any of the AIS data. And he was doing some stuff with Victron charging equipment, so Bluetooth linking. But he's probably running very similar modules, LVGL, SD card, you know, all those things. Yeah, it was just yesterday. I couldn't quite believe it. I'm doing this talk today, and I saw Practical Boat Owner. Someone was doing something quite similar.
Yeah.
So, do have a look at that. If you look up Practical Boat Owner, you'll see. I should get in touch with him really and see.
You should really. I was going to ask Richard later on if I could have your contact details so that I could put the two of you in touch, because what you're doing and what he is doing, from a layman and a non-sailor, looks very complementary. Now, the big thing you're doing, which he isn't doing yet, is using AI. And he just joined another computer club of which I'm a member. He joined last week. And we've got an AI coding section. And he's very, very interested in that.
Okay, well, that's brilliant. Please do pass my details on to him. I saw the article and I wondered, he's also a catamaran sailor, which I am, which is quite funny. We normally know each other if we're in the same neck of the woods, so I imagine he's in a different part of the country, but...
Well, he sails out of Hailing Island.
Oh, okay. Yeah, it's a little bit further round. I sail out of Benfleet area, so... But anyway, I'd be delighted to talk to him and delighted to see what we can do to collaborate, by all means. Any other points? Would you like me to quickly, you want to get home, or shall I show you a little bit of AI stuff?
Quick AI stuff would be nice, I think.
It might be a bit disorganized.
So 5 minutes or so.
One more question.
Yes.
I was just trying to look up what we were discussing, but I think I missed the part about specifically the display and what the display is.
What this is?
Yeah.
It's a Gwission. It's a Gwission. It's got some long number here. It's an ESP32 4848 S040C, right? So this is, but there are two variants, and I'm not sure if these ones are reduced because they've got some PCB problem or something, but it works fine, and it comes with demonstration software that runs on it. So I knew it worked. But the numbers on there, and I put the number in the, I think it's in the presentation, but it's on this box anyway. Take a photo of the label there, and that's that model that I'm using. Okay, so I'm trying to sit down for a minute. And now stop share. And I'm now going to share the okay, so now in my development environment, got my network analyzer. Have we got some camera here, Richard, that I can just show this quickly? Can they see me, or is that just me?
You thought?
This is a little network analyzer I made. It connects to the Wi-Fi, and it lists all the clients. And you can also, you know, scan the ports on the client, or and what's kind of neat about this is I put the OUI database of MAC addresses on the SD cards. The entire 6 gigabytes is on there. I indexed it. So when it sees a client with a MAC address, it says, oh, this is probably an Apple, or this is probably, and they're all on the SD card. So that's quite a neat thing. So it demonstrates the SD card, the LVGL, and the Wi-Fi stacks. That, you know, so I put this together a few days ago, partly because I thought it'd be a good thing to do, and I think there's quite a few other applications I'm thinking I could do with this as well. So here we are. We're in the development environment. This is the main program, and on the right panel here, I have my code pilot. I think you're going to find this difficult to see, but one of the things I left out of this when I developed it deliberately, so I could demonstrate it to you now without ever having mentioned it to the AI, is that when I scan Wi-Fi networks here, it lists the networks. Is it going to list the networks? Give it some time.
Carl, can you hold it up near your face so we can see it?
Yeah. Oh, it's just rebooted. That's not a good sign. Maybe it's just me wiggling the wires, but I'll just wait till it comes up. I'm not sure you'll be able to. It's scanning. Oh, it's listed Wi-Fi networks. I don't know if you can see, but there's all the Wi-Fi networks you can see here. And it doesn't tell me what channel is on which Wi-Fi network. I haven't tried to ask it to do this. I kept this back and thought, I'll try and ask it to write the software to do that. So now I'll put this down. I'm now going to go to, let's use Claude Sonnet 4.5, it says down here. And I'm going to say to it, I'd like to add the channel, the Wi-Fi. I'm going to put Wi-Fi channel to the networks display, so that I can see what channel is being used by the visible networks. So I've asked Claude to change, basically, you know, that's what I want to do. I haven't asked him to change the software. I've made some typing mistakes. You don't have to worry about that too much. Okay, so it's a statement, not more than a question. So I ask it here. Here we go. I'm running over the pub Wi-Fi network, so. And it is evening now, so the Americans are all probably bothering it. It's normally quite quick, but that's not particularly quick. So it tells me what it's doing now. It's searching for bits of the code. It's reading my main program. It's what.
Could you full screen that?
You could try and full screen it. Yeah, you don't need to see, well,
Don't need to see.
you will need to see this in a minute because we'll need to see the result. Anyway, I'll tell you what it says. It says perfect. Claude is saying to me, perfect. Now I can see the structure It's hidden behind my window, so I can't read it. It's made some changes on my program. So this green and red says it's deleted two and created.
Maybe in the top right where it says view.
Yeah, that's okay. That's okay, probably. Yeah. So I don't know if you can see my pointer.
Yeah, I see that.
There it's saying I've deleted 6 lines and deleted 2 lines and inserted 6 lines. Done, he says. Can you read it, Richard? Because I can't actually read it on here because I've got a window in front. Maybe I can drag this away. Yeah, here we go. Done. Wi-Fi channel now will be displayed for each network. I've changed the channel, capture the channel, display channel in the network list, updated debug output to show the channel, upload the code, and you should see the channel number. Now, you know, it says, it always says this. It always says, yes, I've done that. It's all perfect. It'll work now. Doesn't always. Anyway, so here we go. I've got to move this down window again.
Sorry to interrupt again. If you press Control and plus, it might it's larger in there.
Control and plus.
Yeah.
Oh yeah, there we go. But I do need to see, I need to reach these icons at the bottom, and I've now put this down thing.
We just pointed out a bit. And one there will collapse it. That one.
Ah, perfect. Right. Okay. So I'm now going to download it. That's this arrow down here at the bottom. I'm going to compile it and download it. Here we go. So I'll just expand this now. This is our dialog that's telling me what's happening. Scanning dependencies. Compiling. I don't know why while I'm expanding it up there, it's showing me something different. I'm not quite sure. That's not normally what it does. Anyway, it's compiling. I'm just going to keep the window small then. Maybe I can just move it.
How do you upload it to the device?
It's going down this wire.
Okay, the USB pen.
Yeah. Only it's not doing anything, is it? Let's try this again. Maybe I didn't click it properly. Linking. So it's linking building.
Oh, see here, is this C?
Yes.
CPV, yes.
I don't know why it's running so slowly. Oh, this is probably running on the laptop, so it's sharing it with the Zoom stuff, so it might have slowed down the compiling. It's normally quicker. Here we go, writing it. It's now writing it to the device. Do you want to try and put me up again, Richard? Let's see. Now writing it to the device, nothing appears on the screen while that's happening. And then it will boot up. Of course, it will boot up and it will try and connect to the network that's held in my little file system. So I will have to manually select, scan the networks. So I do that. It should look for network. Da, 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 da. Channel 1, channel 1, channel 1, channel 1, channel 3. Why are they all on channel 1? I don't know. So this is the kind of thing that can happen. But anyway, I now have channel displayed in there. I don't think you can see it. I can only just see it myself. I've got glasses on. So for each network, it now explains, the DBM, what strength it is, the channel number, and the encryption type. So the channel number has now been inserted in there. I'm a bit suspicious because I've got channel 3 on one of them and the rest are channel 1. So I'm a bit suspicious about that. So I could say to the AI, so that is good. However, I am seeing channel 3 for one network and all the others are channel 1.
It says a lot on channel 1. Yeah, mostly are on channel 1.
Oh, they are on channel 1.
Yeah.
Oh, we've got look at that.
They are on
Yes,
channel
they are on channel 1. Okay, there we go.
Channel 3.
Okay, yeah.
SGIOT.
Okay, there we go.
Edit Office.
So it's working.
Yes.
Yeah, it's working.
So blame the AI.
Okay, so it's not the AI. Well done. So, but the AI would investigate if I said that. It probably would think that was odd too. Anyway, that's fine. So, and of
Very
course,
cool.
I could color code them or do whatever. And I have asked it to do something quite simple here, but I wanted to do it quickly, and I wanted to see what goes on. But this, if I wanted to ask ChatGPT, I would just select, and here's all that's available: ChatGPT, Raptor, Claude, Gemini, GPT-5. Those are the ones I've got, and Grok. So I paid $10 a month for this at the moment, but there's a free service as well you can play with. So that's roughly what it looks like. And then
Very cool.
my changes appear on the left, and I can commit them or not. So I'll commit this change. It looks good. Commit the change. That will go, and I say what it is. Added channel number. I save that, and that goes through to my GitHub. My GitHub repository, which you're all welcome to download from. So I need to give you the details of that, and I haven't got them on the presentation. Apologies. I'll find them now and put them up.
Very cool.
Any questions about that?
Yeah. Have you found the structure of the language you use and asking the questions has a big effect on the results you get?
Absolutely not.
Oh.
So it can quite easily transition from one language. It hardly notices. It's these are large language models, principally large language models is what's going on here. So from the history of the tokens you've just given it, it's going to tell you what the next tokens are. And it appears to understand your objectives, but they have done some work with giving continuity to objectives, but mainly it comes out of the large language model. So if you change language, it hardly notices, doesn't skip a beat. It couldn't care less what language it is. It seems to work pretty well. So, the test script for this Pi was written by the AI as well. I said, I want to record this AIS stream, and I want you to add these data things in. And that was in Bash or Python or something. It generated the file for me. That would have been so painful to do yourself. Honestly, incredibly painful. Did it perfectly.
Does it actually have to know the language? Like, is there?
No, I don't think it does.
It knows it.
So it actually knows the language.
I've already made commits written by the AI in the language I'm writing a moment before.
Wow.
Because because of how it works. Because it's looking at history. So it's
That language is not that original.
No.
Anyway, it's very much fun to play with, especially when, in the early days, I was getting ChatGPT to write something. I was copying it out, pasting it in. Maybe I was missing a character off the end and it wasn't compiling. And now it just reaches in there using your editor and changes it for you. You can see the changes it's done. You can, did I commit them? I think I committed them. Oh, there's one change somewhere. I can't do it now, but but it will show you the differences between the files, keep your complete history. It really is, it is a bit like, you know, you see Captain Kirk sitting on the bridge of the Enterprise saying, you know, show me all these things, show me, you know, the correlation between tachyon emissions and habitation, and the computer does boom, and it's very much like that here. I'm not talking to it, but I'm typing to it, and it's an incredibly powerful tool, and it's not going to be long. Once it can learn to, every time it makes a change, to leave it simpler than it found it, then it's going to be incredibly good. At the moment, it just gets a bit more complicated each time, and sometimes you say, no, I don't like the amount of complexity you've added for the simple function. So you pull the carpet from underneath it, roll it back, and say, try you doing it this way.
Very interesting. Well, thanks very much. It's very
Okay.